Hello dear students, this is Priyanka Upadhyay, your physics teacher, and today we are going to learn a fourth part from the chapter 3 Laws of Motion ICSE class 9. So now we will learn about Newton's third law of motion. In the previous video we have discussed about Newton's first law and Newton's second law of motion. So here we will study about the Newton's third law of motion. See here, Newton's first law tells us that to bring a change in the state of rest or in the state of motion of an object, a force is needed. That is, a force produces a change in velocity of the object. And Newton's second law tells us about the magnitude of acceleration produced by the force when applied on the object. So, these two laws do not explain how force acts on the object, and this question is answered by Newton's third law of motion. The Newton's third law of motion states that to every action there is an equal and opposite reaction, and they act on two different bodies. So just consider a book which is lying on the table. See here, the book, the weight of the book acts vertically downwards, but the book does not move downwards. It shows that the resultant force on the book is zero, which is possible only if the table is also exerting an equal amount of upward force on the book, which is equal to the weight of the book. Okay, so this force on the book balances the weight of the book. Here what is happening? The book is lying on the table, so that book is not falling down because the force of book is acting in the downward direction, and the same amount of upward force is acted by the table in the upward direction. Okay, so one more example we will consider. While moving on the ground, we exert force by our feet to push the ground backwards, and the ground exerts the same amount of force on our feet. Okay, on our feet, which will be in the forward direction and which helps us to move ahead. So, in these examples, we can observe that there are two forces. There are two forces and there are two objects. In the first example, there was a book, okay, and also there was a table. Book was uh, the weight of the book was acting in the downward direction, and the weight of the table was acting in the upward direction. And in the second example, the weight of our feet. Okay, we are exerting force in the downward direction. Okay, so force exerted by our feet on the ground is force of action, and the force exerted by the ground on our feet is force of reaction. So there are two forces. Book is lying on the table, so book is the action force which is acting downwards, and there is an equal and opposite force which is acting in the upward direction, that is force acted by the table. Okay, so thus Newton's third law of motion states that in an interaction of two bodies A and B, the magnitude of reaction is equal in magnitude of the action, but they act in opposite direction. So we will understand this by the given experiment here. See here. To prove that action and reaction are equal and opposite, we will perform a simple experiment. Look here. Take two spring balances A and B. This is A and this is B, connected together. Okay. Fix the spring balance B to a rigid support. So fix the spring balance B to a rigid support. Okay. When the force is applied by pulling the free end of the spring balance A, force is applied by pulling the free end of spring balance A. Both the spring balances show the same readings. Pull it, when you pull the spring balance A, what happens? Both the spring balance shows the same readings, and this shows that the force exerted by the spring balance A on B is equal but opposite in direction to the force exerted by the spring balance B on A. So the force exerted by the spring balance A is on B, and it is action force, and the force exerted by the spring balance B on A is reaction. Okay, A is pulling B, that is action force, and B is also pulling A with the same amount of force, with 100 Newton force. Here in this example you can see, so that is reaction force. Okay, so we will go through some of the examples. The first example is, when a bullet is fired from a gun, it exerts a forward force on the bullet, and the bullet exerts an equal and opposite force on the gun and the gun recoils. Here, when bullet is fired, what happens? Bullet exerts forward force. Bullet is moving forward, so that is action force. As a result of the action force, there should be a reaction force. There should be a reaction force. That is the reason what happens? Gun recoils. That is reaction force here. So this reaction force is equal in magnitude but opposite in direction. Here you can see the action force is in the forward direction and the reaction force is in the backward direction. Here, second example, when a sailor jumps out of a boat, he exerts a backward force of the boat, and the boat exerts an equal and opposite force on the sailor, and the sailor jumps forward. So whenever he wants to jump from boat to, okay, from boat, what does he do? Okay, he exerts a backward force of the boat. Okay, he exerts a backward force of the boat and on the boat, and boat also exerts some amount of force on him that will be in the forward direction, and that helps to jump. That helps to jump. Next one, see here. When rocket is fired, the force of the burning gases coming out exerts an equal and opposite force on the rocket. Okay, and it moves forward. So what happens here actually is, in a rocket, fuel is burnt inside the rocket, and the burnt gases at high pressure and high temperature expelled out of the rocket through the nozzle. So therefore, rocket exerts action on the gases to expel them through the nozzle backwards. The outgoing gases exert an equal and opposite force R on the rocket, due to which it moves in the forward direction. Okay, so here the gases are coming in the downward direction, that is action force, and due to the action, what happens? Rocket moves in the opposite direction, and that is reaction force. There are some more examples, so I'll discuss with you. See here, as we know, a book kept on a table. When a book is kept on a table, okay, what happens? Book exerts a force equal to its weight, that is action force, in the downward direction, and table balances it by the upward force. Upward force is reaction force in the upward direction. Okay, so next example, some examples we'll consider. Pushing a wall. So when you push a wall, what happens? You're pushing a wall, that is action. With your palm, you're pushing the wall. Wall also exerts some amount of force, not some amount, same amount of force on you, and that is reaction force. That is reaction force. Next one, motion of a boat moving away from the shore. Motion of a boat moving away from the shore. When a boatman wants to move the boat away from the shore, what happens? He pushes the shore by a bamboo or with his oar. It means pushing the shore is action, and shore also pushes the boatman along with the boat in the forward direction. That is reaction force. That is reaction force. Next one, motion of a boat in water. So to move a boat ahead in water, the boatman pushes the water backward with his oar, and that is action force. He is pushing the water in the backward direction, that is action. Okay, so there is an equal and opposite force created. That is the reason boat move in the forward direction, and that force is reaction force. That force is reaction force. See here, motion of a boat away from the shore while stepping down from it. So when you want to step down from the boat, when you here itself we will consider in this example, if you want to step down from the boat, what happens? You exert the force, that is action, on the board of the boat. So there is a creation of reaction force which enables us to step out of the boat. At the same time, what happens is the boat tends to leave the shore due to force exerted by the man. That is, due to action, the boat wants to leave the shore. So for the safety of passengers, boatman always ties the boat to a pole on the shore so that it does not move away. So this is about Newton's third law of motion. So the Newton's, once again I'd like to explain this one. Newton's third law of motion states that to every action there is an equal and opposite reaction. To every action there is an equal and opposite reaction, and these action and reaction will always act on two different bodies. Action and reaction will always act on two different bodies. Okay, next we will study about the part D, that is universal law of gravitation. Universal law of gravitation. Here, each mass particle of the universe attract other mass particle. The force of attraction between two particles because of their masses is known as gravitational force of attraction. For the magnitude of this force, Isaac Newton gave us a law known as Newton's law of gravitation. Known as Newton's law of gravitation. See, according to this Newton's law of gravitation, what does it state? See, it states that the force of attraction between two bodies, is directly proportional to their masses. Here you can see F is directly proportional to the masses. Here F is directly proportional to the masses. G m1 m2 divided by r square. G m1 m2 divided by r square. Okay, and inversely proportional to the square of distances between them, and inversely proportional to the square of distances between them. This is about the Newton's law of gravitation. Now next we will go to the importance of Newton's law of gravitation. Just a minute. Okay, so we will go to the importance. So Newton's the gravitational force. What is the importance of this law? The gravitational force holds the solar system together. If there is no gravity in the solar system, the celestial objects have moved in any direction, okay, without any force of attraction. But there is a force of attraction called gravitational force. That is the reason in solar system all planets are there. Okay, they are held with some gravitational force. Second one, holding the atmosphere near the surface of Earth. Earth is having gravitational force. That is the reason it holds the atmosphere. the flow of water in the rivers. See here, if there is no gravitational force, so where should the water go? It should follow any path. So there is a gravitational force on the earth. That is the reason the water flows in the river on the land. See here, for rainfall and snowfall. Snowfall, if there is no gravity, where should the snow and rain go? They could have went in any direction. They couldn't have reached the earth. Now there is a gravitation, that is gravitational power. That is the reason rain falls, snow falls on the earth. Motion of the moon around the force. So there is a gravitational force between earth and the moon. So that is the reason moon that is the reason moon rotates around the earth. Moon rotates around the earth. See, there will be occurrence of tides in oceans. This is also due to the gravitational power. This is also due to the gravitational power. So see here, Newton used this law to explain the motion of planets around the sun, the motion of the moon around the earth, and the motion of free falling body. If you throw something up, always it comes down. It is because of the gravity. It is because of the gravity. So now we will study about force due to gravity. Here. According to the law of gravitation, the earth attracts each object around it towards its center. The force with which the earth attracts a body is called force due to gravity. The force with which the earth attracts a body is called force due to gravity. Okay, so which can be taken to act vertically downwards and towards the center of the body. Okay, towards the center of the earth. In vertical motion near the earth's surface, the height much smaller than the radius of the earth, the force of gravity on the body is assumed to be same throughout. Okay, so if we consider the force due to gravity on a body of mass m kept on the surface of earth of mass m. Okay, and the radius between these two bodies is r. So the force of attraction between the two bodies is given by F is equal to G capital M into small m divided by r square. Here F is the force of gravity, G is the gravitational constant, M is the mass of the object. This capital M is the mass of the earth and small m is the mass of the object which is kept at some distance, and r is the distance between the object and the earth. So if we substitute the value of force here, if we substitute the values, so we will get the value of acceleration due to gravity. If m is 1 kg, if we consider the mass as 1 kg and capital M, mass of the earth is 6 into 10 raised to 24 kg, and radius between the mass 1 kg mass and the distance between 1 kg mass and the earth is 6.4 into 10 raised to 6 meter, then G will be the gravitational constant. G is gravitational constant. The value is 6.67 into 10 raised to minus 11 Newton meter square per kg square. So if you substitute, you will get the value of F as 9.8. Okay, so next we have acceleration due to gravity. The force of gravity produces acceleration in the free falling object. So there is a force of gravity. Due to that, what happens when body is at some height and when it falls? So what happens? What happens? Acceleration in all free falling objects. There will be gravity. The gravity produces acceleration in the body. So the force of gravity produces acceleration in all free falling objects, and this is known as acceleration due to gravity. It means that acceleration of objects due to gravity does not depend upon mass. Even if the mass is small, then also what happens? It attracts the object, it attracts the body with the same force. And the acceleration of free falling objects, okay, is how much? It is 9.81 meter per second square in the downward direction. Okay. Okay students, so now we will study about free fall of a body. So what is free fall? If you take an object and if you place it at height h and you will allow it to fall. So it will fall in a straight line and it will reach to the earth. So in this case, see a motion of a freely falling body from a height or the motion of a body thrown vertically upwards from the surface of earth is one-dimensional motion. We have studied this one. Motion of a body in a straight line is one-dimensional motion under the gravity. So the acceleration of a vertically falling body, that is A, will become equal to plus G. And if the body is going vertically upward, then A will become minus G. If a body falls from rest freely from height h under the gravity, u is equal to 0. See, if a body falls from rest, then initial velocity will be 0. Initially the body was at rest, so initial velocity will be 0. And the acceleration a is replaced by g, that is acceleration due to gravity. Then the equations of motion are. So we know that what are the equations of motion? U is equal V is equal to U plus AT. See here. V is equal to U plus AT. So in this case, initial velocity will become 0 and this acceleration due to gravity, this acceleration will become acceleration due to gravity. Therefore, it takes the form V is equal to GT. Okay. So second one we have S is equal to UT plus half AT square. S is equal to UT. S is equal to UT plus half AT square. So in this case, S will become the height. Okay, displacement will become the height. And then here U is equal to 0, then this term will become 0. And this A will become G. Therefore, what you will get? You will get H is equal to half GT square. You will get H is equal to half GT square. Third one, you have V square is equal to V square is equal to U square. Okay. Okay, third one we have V square is equal to U square plus 2AS. So here what happens? This U square will become 0, this A will become G, S will become H. So therefore it will become V square is equal to 2GH. It will become V square is equal to 2GH. But if the initial velocity of the body is U, if it has some initial velocity, then what happens? Then these equations of motion. V is equal to U plus AT will change into V is equal to U plus GT. Okay. S is equal to ut plus half at square will change into h is equal to ut plus half gt square. Okay, so what is changing here? This one, instead of s it is h and instead of acceleration it is g. So next we have v square is equal to u square plus 2gs. So in this case, so what will change? This acceleration a will change to g. Therefore it will take the form of v square is equal to u square plus 2gh. Okay, so next we will go for the third free fall of a body is here. If a body is thrown vertically up, then what happens? The velocity of the body will become zero. Okay, and height will be h. Sorry. Okay, if a body is thrown vertically up with an initial velocity u to height h, there will be retardation because the body is going up. It means there will be a retardation in the body. So A will become minus g. Then the equations of motion are, see here, V is equal to u plus at. So plus A will become minus g. Therefore V is equal to u minus gt. S is equal to ut plus half at square. So here instead of a it will be minus g, therefore ut minus half gt square, and instead of h it is height. Third one, v square is equal to u square minus 2gh. So what is the actual form? V square is equal to u square plus 2as. So instead of a we are writing minus g, and instead of s we are writing h. So at the highest point of reach, final velocity will become 0. Okay, thus the maximum height reached will be u square divided by 2g. At the maximum height, what happens to this equation? V square will become 0. Therefore, u square is equal to 2gh. Okay, then h is equal to u square divided by 2g. From this equation, we can calculate that one. Okay, and time taken will be this. Okay, time taken will become u minus g. From v is equal to u minus gt, because this v will become 0. Therefore, it will be u minus gt is equal to 0. That is nothing but u is equal to gt and t is equal to u minus g. So the same will happen to the time taken to come back to the initial point after reaching the highest point. So the total time of the journey will be t dash is equal to 2u divided by g. And the total distance traveled by the body will become h dash is equal to 2h. That is nothing but u square divided by g. So this is about the free fall of a body. Next, we will go to mass. So in the previous classes, you all have studied about mass. So what is mass? Mass is one of the fundamental physical quantity. Okay, and it is a matter contained in a body. Mass is the matter which is contained in the body. So we can define the mass as measure of amount of matter in the body. So consider any body, in that it consists of some matter. So the matter contained in a body will become mass. And this mass is measured in terms of kilogram. This mass is measured in terms of kilogram. Usually in our daily life while speaking, we mix mass and weight. But actually in physics, mass is something different. Mass is the matter contained in a body and it is measured in terms of kilogram. And mass is a scalar quantity. Mass is a scalar quantity and it is measured by beam balance or physical balance. Okay. Next we have weight. So what is weight? Weight is the measure of force of gravity which is acting on a body. Consider a body. Okay. So what happens? So if you leave it, it will fall down. It means some force is acting on the body. Okay, so some force is acting on the body and that will become weight. It is the measure of force of gravity acting on a body. See here, earth will attract every body towards its center. So now what happens? The body will become weight. See here, it is the measure of the force of gravity. So due to gravity, okay, gravity pulls the object towards it and that will become weight. The formula for weight is given by weight is equal to m into g. This is nothing but the relationship between mass and weight. Okay, so here W is equal to mg, where m is the mass of the object and g is the acceleration due to gravity. So weight is nothing but force. So SI unit of weight is same as force. SI unit of weight is Newton. Okay. So I have made some mistake here. It should be a small n. It should be a small n. Okay. So the gravitational unit of weight in MKS system is kilogram force, and CGS system it is gram force. And 1 kg is equal to 9.8 Newton, and 1 gram force is equal to 980 dyne. 980 dyne. So this is about weight. So let's see the differences between mass and weight. The first difference is definition itself. Mass is the matter contained in a body. Mass is the matter contained in a body. But weight is the gravitational force with which a physical body is attracted towards the center of Earth. Okay, center of Earth or any other celestial objects. Here, mass is the fundamental property of matter. Weight is not a fundamental property of matter. Here, mass has magnitude, but it does not have any direction. That is the reason it's a scalar quantity. Weight, we know that something is pulling it. Okay, so it has direction also. That is the reason it is a vector quantity. Mass of a body independent of the location where it is measured. So wherever you go in the universe, mass will remain same. But if you go on different planets, your weight will vary. That is due to acceleration due to gravity. That is due to the change in the gravity. Okay, so mass is measured using pan balance, inertial balance, or electronic balance, and weight is measured using spring balance. Okay, so the SI unit of mass is kilogram, SI unit of mass is kilogram, and CGS unit of mass is gram. The SI unit of weight is Newton because it is a force, and CGS unit of weight is dyne. Okay, so the dimensional formula, it is not there in the syllabus, so we will skip this one. Okay, so this is about the differences between mass and weight. Next, just a minute. Okay, so we will go to the gravitational units of force. This is the last part from your this chapter. Okay, so in MKS system, what happens? In MKS system, the gravitational unit of force is kilogram force. Kilogram force. So what do we mean by kilogram force? It means 1 kilogram force means it is the force due to gravity on a mass of 1 kg. So 1 kilogram force is, it is the force of gravity of a mass 1 kg. So 1 kg of 1 kilogram force is force due to gravity on a mass of 1 kg. So therefore mass 1 kg into acceleration due to gravity. So that is in terms of G Newton. Since average value of G is how much? It is 9.8 meter per second square. Therefore 1 kgf is equal to 9.8 Newton. It is equal to 9.8 Newton. And in CGS system, the gravitational unit of force is gram force. 1 gram force is, it is the force of gravity on a mass of 1 gram. 1 gram force is force of gravity on a mass of 1 gram. If I take 1000 kgf, it means force of gravity on a body of 1000 kilogram. Okay, so next, this 1 gram force is nothing but force due to gravity on a mass of 1 gram. So that is nothing but 1 gram into force of gravity is nothing but acceleration due to gravity. Therefore, it is gram into centimeter per second square. So it will become gram into dyne. Centimeter per second square is dyne. So average value of G is 980 centimeter per second square. That we can write it as 1 gram force is equal to 980 dyne. 1 gram force is equal to 980 dyne. So here we will finish with our third chapter, motion in one dimension. So please go through the notes and the textbook. Okay, so study well, take care, bye bye.